So let's show the SystemVerilog for our memory arrays. So this is a 256 by 3-bit RAM. So the word size is 3, and we have our address size is 8. So we have 2 to the 8, kind of that's the depth, 2 to the 8 words, or 256 words. And so we have our inputs, clock, write enable, A, and we also have write data. So this is a single ported memory, but its port is can be read or written. And so our read is performed, we read this array combinationally. So we have this RAM array that's depth is 0 to 255 or 256 words, and its width is 3 bits. So here's the width, this is the depth. And we read, so our read data, rd, is going to be equal to whatever value is stored at address A in that RAM array. And we're going to write, well, we want to only write at the clock edge because we want to make sure the data that we're writing, that write data, WD, is stable. So, and we want to not only make sure that's stable, but make sure we actually want to write the array. So we're going to have this write enable. At pause edge clock, if write enable, then RAM at address A gets written with the write data, with this 3-bit write data input, WD. So here's a SystemVerilog ROM array. It's 128 by 32 bits, so its width is 32 bits, that's the word size, and it has 7 bits of address. So 128 is the depth, or 2 to the 7. And you'll notice that this only has a single input and a single output. So it has the address input and read data, RD, as the output. And so this ROM is initialized with the contents of a file, in this case memfile.dat, and is initialized from that file. And then whenever we get an address, it just combinationally feeds out whatever data is at that address in the ROM array. And so we can look, and here are the contents of that data file, memfile.dat, and it can contain up to 128 lines of 32-bit hex numbers. So address 0 would have that value, 0, 1, 2, 3, 4, 5, 6, 7. This is address 1. This is address 2. This is address 3, and so forth. We can also have memories with multiple ports. So a port is an address data pair. This example below, we have a 3-ported memory. It has 2 read ports and 1 write port. The array is still the same. There's still a single array, memory array. In this case, we have our address size is n bits. So this is a 2 to the n by, that's the depth, and the data size is m bits, either the write data or the read data. So we have a 2 to the n by m bit array. It's still a single array, memory array, but we can read 2 addresses at a time and write to a 3rd address all at the same time. So here's our 2 read ports, address 1, read data 1, address 2, read data 2. There's the 2 read ports, and then we also have a write port, address 3, write data 3, and then we also have this write enable 3. And so this small memory will be written when write enable 3 is 1, and we get a clock edge. We'll write whatever address is indicated by address 3, and it will write the data value on WD3. And we'll use these multi-ported memories to implement register files in Chapter 7 for storing a bunch of values and then accessing them through both reading and writing. Here's the SystemVerilog representation of the memory array, that small multi-ported memory array that we just showed. This is a 32 by 32 bit register file. So the depth is 32 and the word size is, or the width is 32. So we're going to need a 5-bit address to access this memory array. And this has 2 read ports and 1 write port. The read ports are RA1, RA2 are the addresses, 5-bit addresses, and the data, corresponding data that's read from those 2 read ports is RD1 and RD2. And then we have our signals for our write port, write address 3, write data 3, and write enable 3. And here's our single array of memory that stores that, all of the memory. And always at pause edge clock, if write enable 3 is true, then we write whatever is in write data 3 to the memory array at write address 3. And then our read is done combinationally. So ignore this part first, right? RD1 is equal to the whatever stored in the register file at read address A, and RD2, the read data 2 is whatever is stored at write address 2. And so we have a special thing in this register file in that, as we'll see in chapter 6 and 7, that register 0 happens to always hold the value 0. So if the read address is 0, then it returns 0. And otherwise it returns the value stored in the register file at the given address for both RD1 and RD2.